All right, so the first one, we have 5 sine of x plus 2 equals sine of x. What am I going to do here? Yeah, numbers to one side, trig functions to the other. So I'm going to subtract the sine x over here. And I am going to subtract the 2 to the other side. All right, so I end up with this canceling out, and I have 4 sine x here. This cancels out, and I have negative 2 here. What's my next step? Divide by 4. So the sine of x equals negative 1/2. Where's your sign negative? Right, there's 2 places where it's negative from 0. So if I'm going from 0 to 2 pi, which is how all of them are going to be for me, there are 2 places on the unit circle where your sign is negative 1/2. It's going to be in the 3rd and 4th quadrant, right? Okay. For your 30-degree angle, or your pi over 6. So should be 7 pi over 6 and 11 pi over 6.
Okay, I got that one.
That is where you're going to find that happening. All right, number 3. This was 2 equals 4 cosine squared x plus 1. What am I going to do here? Yeah, I'm going to subtract 1 from both sides. I will get 3 equals 4 cosine squared of x. Next step.
What is it? 1.
It would be 1. I added.
Like, oh, I'm way wrong.
It would be 1. 1 cosine of x. All right. What do I do next?
Divide by 4.
Divide by 4. So I get 1/4 equals cosine squared of x. Yep, square root. What's the square root of 1/4? Positive or negative 1/2? There are 4 places where you get positive or negative 1/2 for the cosine. Where's your cosine 1/2? That's for what type of angle? Pi over? Threes. So your pi over 3s, and they want both positive and negative. So that's 1st, 2nd, 3rd, 4th quadrant where there's a pi over 3. So that's going to be 4 answers. X is going to equal pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are your answers. All right, this is number 21. We have cotangent squared x plus cosecant of x. Does that help us?
No.
What do I need to do first?
Subtract the 1.
Okay, so this guy should ring a bell.
Yeah.
I know that the cotangent squared of x plus 1 equals what? Cosecant squared. I really need to replace my cotangent squared, so I need to move that 1 over. So my cotangent squared of x equals cosecant squared of x minus 1. Yes? So I can replace this guy with cosecant squared of x minus 1 plus cosecant of x, and that equals 1. So I do need that equal to 0, yes. Now I could probably move that 1 over. And so I have cosecant squared of x plus cosecant of x minus 2. And that equals 0, right? And yeah, I can factor that. It's basically x squared plus x minus 2. Factors of 2 that subtract to give you 1. What are they? Factors of 2 that subtract to give you 1. It's a prime number. 2 and 1. Which one's positive and which one's negative?
2 and negative 1.
Yeah, 2 and negative 1. So I'm going to say, I factor this by saying the cosecant of x plus 2, cosecant of x minus 1. X plus 2, x minus 1. Right. All right, so let's look at this. Set the first one equal to 0. I have cosecant of x plus 2 equals 0. Subtract 2. Cosecant of x equals negative 2. What is the cosecant of x in reciprocal functions?
1 over sine.
The 1 over sine of x, right?
Yeah.
So if cosecant is negative 2, what is sine? Negative 1/2. Everybody see what I did there? Okay. All right, let's look at the other side. Cosecant of x minus 1 equals 0. So cosecant of x equals 1. If the cosecant of x is 1, what is the sine of x? All right. There are two places on the unit circle where your sine is negative 1/2. Where are the two places where your sine is negative 1/2?
1 second.
Pi
2 pi over. No.
No, 11
No,
pi
hold on,
over
I think-
6
hold
and
on.
7 pi
It's-
over
We
6.
just did it. 7 pi over 6 and 11 pi over 6. There is one place on the unit circle where your sine value is 1. Where is that?
And it is
Oh, that's pi over 2.
pi over 2.
Sum and difference. So the first thing I'm going to show you are the identities, and then I'm going to show you how they're used. All right. So basically, if you have the cosine of two angles added together, you can actually find that cosine by taking the cosine of the two angles multiplied and subtracting the sine of the two angles multiplied. So what does that mean? Well, that means you're using your unit circle. This is when you're trying to find exact values. So of course, if I were to say something like the cosine of, let's see, we'll do something like something that's not on my unit circle. What's the example that they give us? If I were to say something like the cosine of a 90-degree angle, you should be able to find that, right? But that also is the same as the cosine of a 60 plus a 30, which means you could actually take the cosine of the 60, the cosine of the 30, and subtract the sine of the 60 and the sine of the 30. Like, that's how it works. All right. Now, why does this help you? Because not every angle is on the unit circle. 60 and 30 are, so is 90, okay? But for those angles that are not on the unit circle, but you could get to it by adding two angles that are on the unit circle or subtracting two angles that are on the unit circle, you can use these formulas. Does that make sense? Now, what I will say is that I do make you rewrite them, so you do need to know all 6 of these formulas. But if you were to forget tangent, that's the one to forget, because what is tangent in quotient identities? What is tangent? Sine over cosine. So if you can find the sine and the cosine of the angle, you have the tangent, right? But that's a big workaround when you're using something like this. So what I try to remind people is to pair them up. So look at the cosine. The cosine, when you add them, you end up subtracting. When you subtract them, you add them. So notice that little anomaly there, okay? Cosine is opposite of the whatever's inside here. But it's cosine, cosine minus sine, sine. See that? And then this one is cosine, cosine plus sine, sine. All right, but it's opposite. This is a plus, that's a minus. This is a minus, that's a plus. So when you're memorizing these, think about that. For sine, it's pretty easy. It's sine, cosine, cosine, sine. It's just the sine and cosine of them, this cosine and sine of them. But it follows. If this is addition, that's addition. If this is subtraction, that's subtraction. So everybody see that when you're memorizing these, all right? Tangent. Tangent follows the sine on top, and it's opposite on bottom. So tangent, you add the two tangents, and then 1 minus the product. For subtraction, you subtract the two tangents, and then 1 plus the product. All right? So you need to start memorizing these. You need to start memorizing these, because you'll have a quiz next week on these.
Shows the identities or
On using the identities, okay? On using the identities. And I think that's scheduled for like Tuesday. Okay. All right, so 15. If you have your unit circle, you will notice there is no 15 on the unit circle. But you can use two angles to get to 15 by subtraction. What are the easiest two angles you think maybe to use to get to 15 by subtraction of the ones that are on there? Yeah. So I would say, well, I'm going to rewrite this, and instead of having the sine of 15, I'm going to say the sine of 45 minus 30. Does everybody agree that that is the sine of 15?
Yes.
So then I'm going to go to my identity. I am subtracting two angles in my sine. And so that identity says I'm going to take the sine of the first one, that's 45 degrees, times the cosine of the second one, that's my 30 degrees. And then I'm going to subtract the cosine of the first one times the sine of the second one. And that will be the answer to this. So now I just plug them in, all right? What is the sine of 45 degrees? 45 is an easy one. All right, what is the cosine of 30 degrees?
Sine 30.
What's the cosine of 45? Square root of 2 over 2. What is the sine of 30? 1/2. So far, so good? All right, we're multiplying fractions. Square root of 2 times square root of 3 is the square root of? 6. Over 2 times 2 is? 4. Square root of 2 times 1? Over 4. We already have common denominators. But you cannot combine those two, so it literally looks like this. I know. Your brain wants to do something else, but you can't. You cannot reduce because those are inside the root. If I could simplify a root, I would. I can't. Square root of 6 is as small as the root gets. Square root of 2 is as small as the root gets. If they were like roots, I would add them, right? But this is the answer. This is all you can do with this guy. This next one I do a little bit differently than the book. So we're going to go off track here a little bit from what the book does. The book separates it into fractions. And while you are welcome to do that, many people struggle with splitting that fraction up. 7 pi over 12 into two fractions. Well, that's like, you could say 3 pi over 12 and 4 pi over 12, and then you would see it's pi over 3 and pi over 4, okay? And so you're welcome to leave it in radians if you want to. I would really recommend potentially changing it to degrees because your brain will naturally see what to do with the degrees, okay? So the book split it up. They split this guy up into pi over 3 plus pi over 4, and that is true. Common denominator would be 4 pi over 12 and 3 pi over 12, which would be 7 pi over 12. But I'm telling you, they get more difficult than that sometimes. Like when you're subtracting, or then you have, it could be 6 and it could be a denominator of 6 pi over 6 and a denominator of 2 pi over 2, right? That would work for a 12 denominator as well. So it's not always as simple as just 3 and 4. There are other things on the unit circle that could give you a denominator of 12, okay? And so then you might be going back and forth and being like, oh, well, that doesn't work, so let me try something else, okay? So the other way to do it is to convert it. How do I convert from radians to degrees? Right, so I'm going to take 7 pi over 12, and I'm going to multiply by 180 over pi. All right? My pi's cancel. Does anything go into 12 and into 18? What, 18? 180. 6 does, right? So that's the first one. So 12 divided by 6 is 2. 18 divided by 6 is 3. So I'm going to have 30. We could do it one more time, right? Yeah, so I can reduce it one more time. This is going to be 1. This is going to be 15. All right? Then 7 times 15 is what? Now look what I have. Now I'm going to say, okay, can I add 2 angles to get 105? Can I add 2 angles to get 105? Yes. So I can do 60 and 45. Are those both common angles on the unit circle? Yes, they are. And so, which is exactly what they did, by the way. They did 60 and 45 with pi over 3 and pi over 4. But sometimes using those fractions, you have a harder time than just getting a number and saying, hey, are there 2 numbers on my unit circle that I can add up to this number versus trying to pair up fractions. Does that make sense? You can do it either way. You can use pi over 3, pi over 4, or you can use 105 and do 60 and 45. I don't care which way you do it, but I want to show you both ways to do it. All right, so then this would be the tangent of 60 degrees plus 45 degrees. All right, the tangent of those two. All right, so what's my tangent formula for adding? So I'm going to say the tangent of the first one
Plus the tangent of the second one.
plus the tangent of the second one over 1 minus the tangent of the first one, tangent of the second one. Okay? All right. Tangent of 45 is easy. That's just 1, right? All right, what is the tangent of 60? Sine over cosine? It's square root of 3 over 2 over 1/2, right? So it's just going to be square root of 3, if I'm remembering correctly. So tangent of 60 is square root of 3. Tangent of 45 is 1. So that's what I have on top, square root of 3 plus 1. On the bottom, I have 1 minus the square root of 3 times 1. All right? Now, remember, what do you think I don't want you to leave on bottom? How do I rationalize this? Y'all remember? We've done this.
Wait, is it the
Multiply by the conjugate, yeah. So 1 plus the square root of 3. This is why we had to do that. This is why we had to do that right there. Square root of 3 times 1 is the square root of 3. What's the square root of 3 times the square root of 3? Just 3. 1 times 1 is 1. And then 1 times the square root of 3. There we go. On bottom, remember it's the difference of the two. The first one squared, that is 1, minus the second one squared, that is 3, right? What happens on top? Combine my like terms. So square root of 3 and square root of 3 becomes 2 square root of 3. And then 3 plus, that should be 1. Why did I write a 4? 1 times 1 is 1. 3 plus 1, oh, I was doing it in my head. Sorry, I was jumping ahead. 3 plus 1 is 4. This is 4. What's 1 minus 3? -2. Now the best way to reduce this is to do them individually, okay? So put 2 over the square root of 3 over -2 plus 4 over -2. All right, that's the best way to reduce that guy. All right, what reduces here? 2 and -2, right? So I just get negative square root of 3, and then 4 over -2, -2. All right, so this looks intimidating. An alternating current I in amps in a certain circuit can be found after 2 seconds using I equals 3 sine of 165t, and I'm going to rewrite it to look like yours. I equals 3 sine of 165 times t, where 165 is a degree measure. It says rewrite the formula in terms of a sum of 2 angles. And so 165 is not on my unit circle, but I can use 120 and 45, which are. So I can rewrite this to look like this. 3 sine of 120 plus, we'll do this, 120 plus 45. T. And those are on my unit circle. It says use the sine sum identity to find the exact current after 1 second. So if I plug in a 1 for that T, right, that's going to be a 1. And then I just need to calculate this. So I'm going to use my sine, which you should have on your little sheets, but if not, it's over here on the next page. So we're going to say 3. Remember, it's sine, cosine, cosine, sine. So sine of 120, cosine of 45, plus cosine of 120, sine of 45. And the reason the t has gone away is just because it's a 1, right? And then we just use our unit circle to calculate it, all right? The sine of 120 is what? The reference angle is a 60. So the sine of a 60 degree is square root of 3 over 2, right? The cosine of 45, that's easy, right? And then the cosine of 120, negative, right? Are we negative? Negative 1/2? All right. And so we will multiply those by 3. And I think they actually distribute it through. So we have 3 square root of 6 minus, minus the square root of 2 over 4 amps. All right. Yeah, so this actually has a 3 in front of it as well. Or you can do that. They distribute it, I think, in the book. Yeah.
You would take both.
Yeah, I'll take either one of those. Those are the same thing. All right. So we have been, think about it with logarithms. We expanded logarithms, we condensed logarithms, right? And so with these, there are times when you're going to be like, oh, I need to expand this out to 2 of them. And then you're going to look at something like this and go, 32 and 13 are not on the unit circle, right? That doesn't help me. But 32 plus 13 is. And so if you see that plus up there for tangent, then you know, hey, that means that those 2 things are added together for 1 tangent. And so then you can condense these into 1 and you can say, oh, well, that is the same thing as the tangent of 45. Period. That whole thing is the formula for the tangent of 45, right? 2 angles added together. You add together on the bottom, you subtract the product of their tangents. That's the formula. So I can condense as well into 1. Well, the tangent of 45, that's way easier. That's just 1. All right, so then I just say, well, what is the tangent of 45? That's square root of 2 over 2 over square root of 2 over 2. Tangent of a 45, since the sine and cosine are the same, is just 1. And I am done.
Whoa.
Okay, so this right here is the same thing as the tangent of 32 degrees plus 13 degrees, right? Which is the tangent of 45, which is 1. This whole thing is the formula. So the tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A tangent of B, okay? So this whole thing condenses to the sum of them. So that whole thing right there condense to the sum of those angles. The whole entire group condenses to the sum of those two.
This is why.
Just like if I had been given the sum of 45, I could split it up into the sum of 32 and 13. Not that I would ever want to do that, but you could, right? Just think of it as like expanding and condensing logarithms. Just because you can go from one direction to the other and the other direction back, all right? This next one is just condensing. It doesn't actually, you can't solve it because there's a variable in it. All right. So the first thing I'm going to look is I'm going to see it says sine, sine, cosine, cosine. All right. So first of all, which of your trig functions groups them with the cosines together and the sines together?
That's the cosine.
The cosine. All right. Now, this is subtraction, so order actually matters. So I need to flip this around. Okay. What I'm actually going to do is I'm going to flip it around. So I'm going to say negative cosine of x, cosine of 3x, plus sine of x, sine of 3x, okay? Because that's how it is in my formula. I also notice there's a negative in front. None of my formulas have a negative in front. Anytime there's a negative that you don't want, factor it out. He's still there, but we're going to put him on the outside here. So we're going to take this negative one out. And I'm going to say cosine x, cosine 3x, minus sine x, sine 3x. That now looks like one of my functions, doesn't it?
Yes, it does.
Which formula does it look like?
Sum identity.
Which identity? Yeah, the sum identity. Remember, cosine's opposite. So this whole thing is going to reduce to what happens when I add them. I keep that negative one in front, but that's going to be the same thing as cosine of x plus 3x. Remember, cosine's opposite, right? Negative goes to positive, right? So what's x plus 3x? 4x. So negative 1 times the cosine of 4x, or you can just write negative cosine of 4x. And you're actually done there. All right, so verifying. We have actually already learned what this is. We know that the sine of a 90 degree minus x is the same thing as cosine. Like remember, those are our, if you look up on your sheet, those are on there, right? So your cofunction identities say, hey, if you have pi over 2 minus the angle, it's the same thing as a corresponding angle. Well, this is a sum and difference, correct? Yes? Yeah. So if I were to do the sum and difference here, this would be the sine of pi over 2 times the cosine of x minus the cosine of pi over 2 sine of x, right? Everybody agree with that?
Yeah.
All right. What is the sine of pi over 2?
Oh, hold on. Give me 2 seconds. I'll figure it out.
All right. Times the cosine of x minus the cosine of pi over 2, which is 0. All right. 1 times cosine is... And this zeroes out, and lo and behold, that is true.